Hello everyone, welcome back. Last video we derived this diagram on the board that describes writing a C++ program, compiling it into machine code, and then running that machine code on your machine as an executable program. I want to emphasize that while this one we derived together, it may be a little hard to read or maybe not as clear, but there is a really nice diagram in the programming language's notes for that video that I took out of a C textbook. So it doesn't use the specifics of like G++ or gedit that we have for our class, but it is a nice diagram that shows this in a little more high level, more clean way. So definitely check out this diagram and compare it to the one that you took in your notes from the last video, and you can see, for example, which word processor we use gedit, which compiler do we use G++, etc. So now in this video, we are going to compile and run that hello world.cpp file that we made in the last video. We know a little bit now about how we get this high-level program to be an executable program. We just need to see it in action, and that's what we're going to do. So for the warm-up task, go ahead and open up your terminal and navigate into the directory that has the hello world.cpp file that you wrote during the last video's warm-up task. Open it with gedit and stay tuned because we're going to compile and run this program. So here's my hello world.cpp file open in gedit. We're going to compile and run this program. While you're getting this all set up, I'm going to go ahead and just talk a little bit about the C++ programming language, just to give you a little bit of a history lesson about C++. So as mentioned in the last video, C++ is based on the C programming language, which is a very, very, very popular, very old programming language that's still widely used. It was developed in 1972 by Dennis Ritchie at AT&T Bell Labs. It was originally designed as a language in which to program the Unix operating system, and you guys have heard me talk a little bit about the Unix operating system. So Mac OS is actually based on the Unix operating system, and so is Linux. Our Lubuntu VM is based on Unix, which means that a good chunk of the code that the operating system that you're using is written in C, which is really, really cool. Going on a little tangent from this, Linux is actually an open source project, which means all of the source code that is used to run the Linux operating system is available for anyone to go view, download, and as long as it adheres to the licensing requirements, modify, which is so cool. Mac and Windows, on the other hand, are not open source. They are proprietary code repositories where the only way you're probably going to see some of the core algorithms behind Windows or behind Mac is if you work there. So open source projects are really awesome. They promote development in the community, they promote community, and really just getting the code out there so that people can contribute to and use it. So in our diagram that we drew earlier, we saw that C is a little bit more low level than, say, C++, Java, and Python, but that makes it really great for applications where memory is limited, like embedded systems or small little projects like Arduino or Raspberry Pi, for example. Now, because C is more low level than some of the other programming languages that came not too long after, C++ was kind of born to be an object-oriented version of C. Those of you who perhaps have taken AP Java classes in high school, you learned object-oriented programming. C++ is the object-oriented version of C. In this class, we're not going to get to the object-oriented part of C, but in the next class, 122, you will cover object-oriented programming in C++. So C++ was developed also at Bell Labs about 10 years or so later by Bjarne Stroustrup. I apologize if I'm not saying that name quite correctly. And it's kind of a superset of C, which means it still has all of C's low-level capabilities for memory management and sorts, but it also has that high-level object-oriented part that you can use. It's designed to support cross-platform programming, which means if you write your code in C++, you can compile it so that it runs on different architectures like Intel or AMD, or even platforms like Windows versus Mac. So hopefully you've got your Hello World code open now and you're ready to try and compile it. So just to recall our development process, or that big pipeline we drew on the board, we're going to enter our source code in a text editor like gedit. We'll edit it as we need to improve upon it. When we're ready to try and run it, we first have to compile it into an object file and link it with other object files to form an executable. The G++ Linux command will do that for us, the compiling and the linking. Then, with our executable file created, we need to load it into memory in order to run our program. So let's do it. So I'm going to do an ls just to make sure that we've got helloworld.cpp in the current working directory. Then we type G++ space, and now a path for the name of the file that we want to compile. This can be relative or absolute. I'll use a relative path. Don't forget about your tab complete. That will finish the file name if you start to type a couple letters of it. And then we press enter. Now remember, there are one of two outcomes that can happen from this step. If your code is syntactically correct C++ code, then you won't get any errors and you will effectively get a .out file that you can run. If your code is not syntactically correct, you will get an error. You will not get a .out file until you come back to gedit, edit your C++ source file, try and recompile it again, repeat until you get no errors. So mine has no errors. I know this because there's no output that tells me there are errors. If yours has errors, then you'll need to start what's called the debugging process. A bug is an error in your program. You've probably heard the term debugging before. And you've got to figure out what is that error and you've got to fix it. Now, let me introduce an error in mine so you can see what it looks like. Let's say I forgot to put a semicolon on the end. This star up here in gedit, this tells me that I have unsaved changes. So Control S to save. I'll use my recent commands history with my up arrow key to execute G++ hello world.cpp again. And now you can see I get an error. Okay, I have this error and it says hello world.cpp. This is the line number. And it says error expected semicolon before return. Okay, well, return is on line number 8. So it's saying there's something, should be a semicolon somewhere before this. So even though this line number tells you where the compiler detected the error, you should treat it as a region in your code to start looking for the error. So we know that the error is actually on the previous line. I need this semicolon here. Now it compiles. I'll do an ls, and here is that .out file. By default, it's called a.out. We can change the name of our .out file, but for now, let's just leave it as a.out. So let me show you one more error. Perhaps maybe, let's say I accidentally capitalized main. Try to run it. I get a different sort of looking error, and this one doesn't give me an exact compiler error. Excuse me, an exact line in the compiler error. Instead, it says undefined reference to main. Okay, so every C++ program has to have something called main. It's the main entry point in your program. When the loader loads up your program and transfers control to the operating system to run your program, execution starts at main. So we need a lowercase m here. So some of the errors are easy to figure out. Some of them are hard. But with practice, you'll start to figure out how to debug these, and you will not have to spend as much time with compiler errors down the road, maybe in a couple months, as you will in the beginning. But just know that compiler errors are totally normal. They happen all the time, nothing to worry about. Part of the problem solving is figuring out how to fix the errors as problems. Okay, great. So now we have our a.out file over here, and we want to invoke the loader in order to run this program. So to execute our program, we don't necessarily use a command that has a name. We use // and then the name of our executable file, a.out. This output right here, hello CPSC 121, that is our program's output. For example, if I come over here and maybe I add a couple smiley faces on the end, save it, don't forget to save it, compile it again, make sure there are no errors, and run it, my output changed. So there's a quick and easy way to confirm this output is coming from the current version of your program, which is really cool. So this is kind of a historical moment in your programming career where for some of you, this might be your first program that you have ever written and that you have ever ran. So definitely take a moment and congratulate yourself on getting this to run. If you have some compiler errors and you can't figure it out, try to figure it out. It's going to be frustrating and challenging, but this is part of the debugging process. Go line by line, character by character, and compare it to mine and make sure that everything matches. If you still can't figure it out, then go ahead and download the helloworld.cpp file that's posted in the same folder as the notes for today, and try and save, compile, and run that one. That one will work because it is this file that I'll upload. And then maybe you could open them both and compare. But if you still can't get it to work after trying all of those things, definitely come and check in with me during office hours. I am more than happy to help you with this. That is what I am here for. So please, 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 challenge yourself to try and figure it out. But if it's taking more than maybe like 20 minutes or so, then come talk to me and we will get this to work. All right, so we just compiled our first C++ program. If you want, play around a little bit with some of this text in here and see how it changes. In our next video, we're going to dive into the details behind each one of these lines of code as we start to learn the basics of C++ that we can use to construct a little more complicated programs than simply saying hello CPSC 121 or hello world.